Homework 2.3, Linear Functions and Slopes, Video 5. Homework due Friday, May 22nd, 2020 at 11:59 p.m. In the previous video, we looked at a couple of examples of setting up point-slope form and then converting it to slope-intercept form. And this one is kind of the same, but it's also kind of different. Take a look at the example and think about why this is a little bit different than the previous problems. Just as a reminder, in the previous video, we were given a slope and a point and asked to build point-slope form and then slope-intercept form. So why is this problem different? It's actually different in two ways. What information are you given? Not a point and a slope. You're not given a slope at all. You're given 2 points. And I'm asking you not just for point-slope form and slope-intercept form, I'm also asking you for general form. Now I'll admit that this example, which is similar to some of the tail end problems in that batch up there, is a little bit more intense than the ones you'll see in the homework. So when you see the ones in the homework, they'll be a little bit tamer by comparison. All right, so let's think about how we're going to get started here. In the previous video, I kind of suggested that you should always start with point-slope form, assuming that you have a point and a slope. But what were we given in here? 2 points. We weren't given a slope. So, is there a point-point form or a 2-point form that says if you're given 2 points, here's how you build the equation? Actually, there is, but we don't need it. Why don't we need it? Because we have everything we need. We have everything we need to build point-slope form. We have a point, we have 2 of them. And although we don't have a slope, we have a formula for slope, aka a recipe for slope, and the ingredients to build it. So it's not uncommon in these write the equation problems to not be given the slope, but be given enough information to find the slope. So let's begin. First, we have to calculate the slope. Now, if I recall correctly, I believe these were the same 2 points in the first video. You can go back to the first video and see, but when we first calculated the slope, I believe the points were 2, 4, and 9, 8. So to find the slope, it's the second y, which is 8, minus the first y, which is 4, divided by the second x, which is 9, minus the first x, which is 2. 8 minus 4 is 4. 9 minus 2 is 7. I do remember the slope being 4/7 in the first example, so I think those are the same points. Now we have our slope. Now we can build point-slope form. So second, we're going to build point-slope form. But now we have a decision to make. Point-slope form requires a point and a slope. I have 2 points. So which one do I use? I know it says x1, y1, and this is our first point, but remember, the order the points are given is arbitrary, so either one of them could be called the first point. If I had called this the first point, both of these subtraction problems would have been backwards. Both of these would have been negative, but the 2 negatives would have canceled and given me the same slope. So we actually have 2 choices on how to set up point-slope form here. We could either say y minus the first y, let's say 4, is equal to our slope, 4/7, times parentheses x minus the first x. Well, if I'm calling this the first y, then 2 is the first x. Or, if for some reason we decided to call 9, 8 the first point, then we would have set up y minus the first y, so y minus 8 equals the slope, which is still 4/7, times x minus the first x, which in this case would be 9. So which one is correct? Both of them are, and the homework knows this. So in a problem like this, it would accept either one for point-slope form. But what about slope-intercept form? We have 2 different point-slope forms. Won't we get 2 different slope-intercept forms? Actually, no. Third, we need to convert to slope-intercept form. And here's where things are about to get a little bumpy. I know earlier I said fractions, don't worry about it, deal with it, but I'm also a realist and know that people struggle with them from time to time. Here's an example of where you might. I know what I need to do, distribute and get the y by itself. But the first move is going to cause me a little bit of trouble, just a little. Y minus 4 equals 4/7 times x, not a problem, 4/7 x. But what about 4/7 times 2? Remember the rule for multiplying fractions. To multiply fractions, you simply multiply numerators and denominators. The 2 not being a fraction can be put over 1. 4 times 2 is 8, 7 times 1 is 7. So 4/7 times 2 is 8/7. Okay, that wasn't too bad, but we're not done yet. Because to finish to finish slope-intercept form, we have to get the y by itself by adding 4 to both sides. Great, now I gotta add fractions. Never fear, we know the rule. The rule for adding fractions is get a common denominator and then combine the numerators. So we need to think of this as 2 fractions. The 4 is not a fraction until I put it over a 1, but now I don't have a common denominator. What's a common denominator for 1 and 7? 7. So I can turn the second fraction into sevenths by multiplying the denominator by 7, but if I do that, I have to multiply the numerator by 7. So adding 4 is the same as adding 28/7, and now I just have to combine these. They have a common denominator, so when I combine them, they will still be sevenths. -8 and +28 is +20. So -8/7 plus 4 is +27. We still have the 4/7 x sitting there, and on the other side we get y equals, and we have our slope-intercept form. If we used that point slope form. Slope-intercept form should be unique because a line has only one slope and one y-intercept. But just to confirm, let's go ahead and do this one as well, and we better get the same results. I think we can go through this one a little more quickly since we've already hashed out all the fraction arithmetic. Distribute the 4/7 and we get y minus 8 equals 4/7 x minus 36/7. If you need to slow down and do the multiplication, that's what you do, but you'll get 36/7 or minus 36/7. I need to add 8 to both sides, but before I write +8, I already know I need to turn it into sevenths. So let me think about that. 8 is really 8/1, multiply both sides by 7, and I get 56/7. Again, you can think a lot of this, or maybe do a little scribbling. The 8's cancel, and we get y equals 4/7 x. Common denominator is 7. -36 and +56 is +20, and look at that, we got the same answer. I am a little dumbfounded that the numerators are 4 and 20. Full disclaimer, never tried this stuff, but that's really bizarre. And if you don't know what I'm laughing about, then I'm not going to explain it. Oh wait, we're not done. I did ask to also convert the answer to general form, because there are some problems in this homework, or the next one, where you have to convert to general form. So we got the slope, we set up both point slope forms, either one would have been acceptable. Both of them ended up being the same slope-intercept form. So how do we get general form out of that? As I just erased general form. Remember that general form's purpose is to look pretty. But general form, and I'll write it again over here, is ax plus by plus c equals 0. First number is positive, no fractions. So let's take our slope-intercept form, y equals 4/7 x plus 20/7, and figure out how to make this in general form. We need to fix what's wrong. One thing that's wrong is this has fractions and general form does not. So, what can we do to both sides to get rid of the fractions? The plan of attack for getting rid of fractions in an equation is to multiply by something capable of canceling the denominators. Just multiply by the least common denominator, which is 7. On the right side, on the left side, we get 7y. On the right side, we have to distribute the 7, but that's okay. Because when this 7 hits this 4 sevenths, the 7's cancel and leaves a 4 on the x. And when the 7 hits the 20 sevenths, the 7's cancel and leave a plus 20. Well, that didn't hurt. And now to get it in general form, I have to make one side equal to 0. But remember, general form also wants the leading term, the x, to be positive. So I'm going to leave it on the right side because it's already positive and move the 7y over. Put it in the middle, and because the 7y is changing sides, it's changing signs. General form is 4x minus 7y plus 20 is equal to 0. I left out that there was one more characteristic of general form. The greatest common factor of these coefficients is 1. For example, if this were an 8, 4, 8, and 20, they would all be divisible by 4. If that happens, you just divide everything by 4 and reduce it until there's no more common factors. So general form, again, goal is to look pretty, but it doesn't contain any information. Where's my slope? Where's my points? Where's my intercepts? I don't know. All right, try questions 6 through 10 of the homework, and I'll see you in the next video.